Hey everyone, Theater 15, let's give it up for Sanchay, our next speaker.
Hey everyone, thanks for coming to this talk about Overwatch. My name is Sanchay. I'm super excited to be here. BSides is where I've learned, I think, most of my security knowledge from, so it's very humbling and, I'm extremely honored to be able to speak here today. Before I actually talk about Overwatch or any of these other buzzwords that you see on the slide, just with a show of hands, how many of you have heard of the phrase shift left before? Okay, yeah, the light's kind of bright, but I think I saw pretty much everyone's hands go up. And obviously shift left is this very powerful concept that's been used in our industry quite a bit. And it's generally, just to refresh everyone's knowledge, it's this idea that the earlier or left that we go into the software development lifecycle, the cheaper security bugs are to fix, and just the more traction we get. And that's fundamentally why we're here, right? We're trying to stop security problems before they become a real problem post-production. And last I checked, which was this morning, AI has not completely eliminated our need for shift left just yet. So I think this talk is still relevant today. And it was about, some of the buzzwords on that slide reference security automation, right? And when we're talking about security automation while referring to shift left, typically we're talking about the pull request stage. It's sort of a phase where developers are pushing some code up, they're looking for some feedback, and we can kind of inject our security feedback somewhere over there. And so today we'll talk a little bit about that pull request phase. And so what's a practical implementation of shift left at a pull request phase? Well, it could look something like this: a simple GitHub Actions file that runs some, my custom security automation. And in 15 lines of YAML, we have shifted left, right? We have a way to funnel feedback to our awesome developers that are just waiting to hear about all these security issues that, we're detecting in their pipelines. But what's one of the challenges with this? Well, this is installed in every repository, and security is an ever-evolving landscape. So as things inevitably change, we have to go modify this in every single repository that we've gone and installed this in. And that's not the only problem. Sometimes we have one version of our automation that needs to run on a set of repositories and a different version on another. And again, we're managing all of this on a repository by repository basis, right? Which can obviously get a little bit dicey. You might say, hey, that's fine. I only have 10 repositories. And I'd say, God, I wish I was in your shoes. Because 10 repositories, I think this approach makes complete sense. But as our organizations grow, what happens when we hit 100? What happens when we hit 1,000? And at Chime, we're closer to that number. And also we understand that there's organizations that vastly outsize us too, right? It just can get pretty dicey. I think, again, we're all bought into this idea of shift left, but I don't think we all signed the dotted line that said, hey, I want to be a glorified pipeline manager for the rest of my security career. In addition to this, as we're adding different forms of security automation, as we identify all these cool tools that we want to just inform developers at their pull request about, this is unfortunately what a triaging experience can look like. For some people, it's navigating through a CI pipeline and parsing the output, figuring out if something went wrong or if the tool just broke. And for other people, it's like logging into single sign-on for the first time of that tool, finding their dashboard and the necessary security vulnerabilities. And this is obviously just a frustrating experience, right? So we're trying to combine these two ideas, this like non-unified vulnerability management way of surfacing issues at the pull request level, and just this growing SRE DevOps type busy work that we didn't really sign up for. And we're like, can we do something better? Because we feel like we can. So let's quickly throw on our product manager hats and go like, what can we build to kind of solve some of these problems? And so one approach, which obviously the paved path concept, very well popularized by Netflix, we're saying, can we use that concept of a paved path, but apply it to enabling and managing our security automation, right? Create one path where we're not reprimanding people for not using this. What we want to do is create an attractive enough solution that people will voluntarily come and choose our paved path to spin up their own forms of automation. And if we truly are able to get a paved path up and running, then we might have a chance of unifying and kind of having an intuitive triaging experience that can come of it, of like one single path. So we're going to try to solve that. We're also going to use some other aspects, right? Like automation should be isolated from each other. We don't want it to impact each other. We also want to ensure that we're lowering the operational burden. We don't want more responsibilities to come. So really any failures that come from this should be async. We don't want anyone to be on call. And lastly, by default, we don't want to play whack-a-mole with our GitHub inventory. It's constantly changing. So by default, everything should just be covered, new and existing. And so that last point is actually the simplest one to address first. If you're on GitHub and familiar with GitHub apps, you can just kind of install this org-wide and you can get events from everywhere. So this part's fine. If you're not familiar with GitHub apps, basically think of them as glorified service accounts with some amount of permissions, fine-grained permissions. You can have it just do very specific things like on pull requests and receive events just related to pull requests. So as we're receiving all these events, like for example, maybe we receive an event that a certain developer has pushed a commit to a pull request, and now we want to do something about it. Well, we have to send these events somewhere. So what we're going to do is spin up a very simple Go web server, and we're going to send events to like this GitHub Events endpoint, right? So we have some place that all these events are landing. And as the name suggests, it says that blue box says orchestrator, right? So it's going to do some orchestration-like things. It's going to decide for a given event, should I run any forms of automation or not? And these forms of automation, as you saw from our requirements, very easily kind of lead us to this Lambda route. They're isolated, there's less ops with them, they're ephemeral, they kind of fit that requirements very well. And as we're going through this, remember, we're trying to reduce the burden on anybody spinning up or using our paved path. What we're gonna do is take any common functionality. So think of parsing a git diff or cloning some code or manipulating in any way that is shared across multiple forms of automation. We're going to have our orchestrator just handle that. Don't put it on the Lambdas. Let's take the burden on the platform and just create that paved path for everyone to walk through. There's two names of Lambdas up there, SemGrep and Brakeman, but they're not the only ones we've integrated. We have 6 today, 1 around the corner, and more coming. And I promise this isn't some type of flex of like, we have more automation than you. Like, that's not the purpose of this at all. This list will grow and reduce in size as required. We're just chasing high confidence stuff that fits into our program, but it needs to be very flexible. So this is just transparency. A little bit more insight into this orchestrator itself. I mentioned, for given requests, should I trigger some automation or should I not? So some examples are like, there's dependabot pull requests and we get tons of them. We don't really need to trigger any automation for that, any security automation for that, because really they're actually opening pull requests to solve security problems usually in the first place. And so this orchestrator is going to filter out these events and decide for any given event, do I actually need to invoke a given Lambda or not? That's one of its core responsibilities. And everyone's definition of scale is, something slightly different. So again, for transparency, we receive, like roughly 22,000 events per day, which is plenty for the Go web server to handle. I mean, it can handle that just fine. Spikes can look like, 3x, 4x this volume, mostly depending on the GitHub activity that's coming in. And roughly 15% of these events are worth acting on. Like at least one Lambda will get triggered for any of these given, for this volume of events, basically. And as you can see from the slide, they're just very cheap to run, in case you were wondering about cost. So this is all great, okay, for a given event, it's deciding what to do, but the orchestrator still needs to know what Lambdas are available, which ones to trigger. And so kind of emulating that CI experience, we have one YAML file, essentially inside the Overwatch repository, where you can define and place your Lambdas that you want to spin up. These have additional certain options, for example, for Brakeman or SemGrep, you can add extensions, certain file names that you want to trigger a Lambda on. These are in addition to some of the core, event parsing that our orchestrator is already doing. But remember, we're only defining this in one place, one YAML file, and you can deploy your Lambda out to our entire fleet through this flow. And so going back to our diagram, a request came in, orchestrator decided, okay, maybe this one's worth acting on. Based on the configurations, we triggered some forms of automation, some of these Lambdas, and using some shared flow, like the S3 flow. And then these Lambdas perform their operations. They go ahead and drop in this case a report to another S3 bucket. So as they're finishing, they're dropping their reports. And as those reports are being generated, we're going to go respond in a sort of unified way back to the APIs we've integrated with, in this case, GitHub and Slack. These are the two that we've integrated with. Yours might look different, but just think of these as replaceable APIs in case anything ever changed. And fortunately or unfortunately, this is not a system design 101 class, so I'm not going to talk about every single failure point that could go wrong, but just think about this diagram as anything should be allowed to fail here. We're not trying to add burden or ops work on any individual or engineer that is maintaining any part of this diagram. So just add, your SNS topics or retries as you see fit over here. And that's something we can talk about later too. Okay, so we talked about unification of alerts a lot. So what does that actually look like? So here's an example of an alert coming from the semgrep Lambda. It's reported inside GitHub and has a pretty intuitive experience. There's some triage buttons here. If you want to know how to fix the alert, you can click on show more details. Now, a lot of this is actually powered by our usage of GitHub Advanced Security. We are partnered with them and we're using these API calls. So it's really not super magical that this alert is showing up. But what I think is cool is that for every Lambda that you integrate with our platform, there is a unified playing field. So now our Brakeman alerts, our MobSF alerts, and every other Lambda you saw integrated, they can all report alerts in the exact same way. You're not logging into a multiple dashboards. You're not trying to find how to fix vulnerabilities. If you've seen even one of these alerts, you probably know how to triage them with some uniqueness to each of the Lambdas. In addition, we want to take the ops down on our security team. We mentioned that. And so our security team generally consumes alerts in Slack, and these are also looking strikingly familiar at this point. And so here's alerts from 2 of our Lambdas, and here's alerts from 2 other Lambdas, and they're all using a very default template that has been defined by our orchestrator. And like anything in this flow, you can override it if you need to. So need something custom, feel free to go add it. But here's the pave path or default mode of operation. One note about those buttons, our source of truth we're using as GitHub. So any triage you do, whether it's a security engineer on the Slack side, or if it's somebody triaging on the GitHub side, fundamentally they're mapping to the exact same alert. We're not syncing alerts across multiple sources. And so this lets us do that. And any unfixed alerts or anything, again, they're living in GitHub. It's our source of truth for code-related, security vulnerabilities. And that's how we use that. And so you might say, okay, this is all fine. Cool that you found a way to slightly unify your alerts. But I haven't dealt with Lambda before, and what does that take? I kind of miss my 15 lines of YAML at this point. So let's kind of break this down. What's in this Lambda? How do you set it up? So we've gotten to the point where all you have to do is add basically one line, which is your Lambda function name, with some optional parameters like timeout or memory. It's going to automatically configure all the necessary resources and permissions that Lambda needs to do its job. And just as a reminder, its job is essentially pulling some code from S3, running its automation, whatever that means, and then uploading a report to S3 if it kind of fits that mold. And so again, if you're not familiar with the code here, this is totally fine. There's basically just 3 functions mapping to those exact operations I just described. Get code, do some automation, dump the report. And so the only bit that's actually unique is that section in the middle. That's the one that all Lambda authors really control, and they can do whatever they want. In semgrep's example, it could be as simple as this one line. Let's look at the difference in Brakeman. It's just a different line, but that run scanner interface is essentially identical. And depending on your automation needs, it can scale up or down. But the point is it's fairly simple. You have the Terraform module, and then you have this one line that you're fundamentally controlling. Everything else is shared and imported. And you kind of probably need a way to test this, right? Hey, I have a Lambda. I want to see if it's working with the orchestrator. I want to see how the alerts are showing up or what it looks like in GitHub. And so if you're familiar with versions and aliases in Lambda, this will be a little bit obvious to you. But if not, just know that there's a way that every time you push a commit on your test branch or your custom branch within your Lambda repository, we are creating versions and aliases of your Lambda that you can pin to and you can use. So as you merge to main or your main production branch, there's a prod version now available. And you can, in the orchestrator, remember that one YAML setting file, not just the Lambda function name, you can also add this custom version or alias to pin to that exact version that you want to run with additional options. And so why is this powerful? Why am I telling you about all these versions and aliases? Well, just because we found a way to spam GitHub in the pull request comments is not what we want to do with all our Lambdas. So a typical rollout strategy would probably look like, hey, I want to take the test version of my Lambda. I want to run it in Slack for a while, feel confident about the rules, maybe a test version on my test branch. Once I'm confident, I can merge that in. I have a prod version now available. And maybe if I'm happy, I can turn on GitHub commenting for that. And that's a little bit more thoughtful. That is not going to ruin trust with your engineering counterparts and gives you a lot to play with. One thing to note is you can actually run multiple versions of the same Lambda, right? Like your prod Lambda and a test Lambda all in one place in parallel. It's all up to you. We're just giving all the options to everyone that wants to roll out this automation. And once again, remember that anytime you define anything here, it's getting deployed fleet-wide across all your GitHub repositories. And so all this also might sound great, but really let's highlight what is happening by separating out all these automations, like by not rolling it up into like one golden image or keeping them all playing together. Really, the Brakeman Lambda can just fail and it should not impact anything else, right? And so typically if you were rolling a Brakeman check, let's say in CI, this is a flag or like, a pipeline failure that a developer might see. If, even if GitHub's down or Brakeman's not operating well anymore. And we really don't want to add this cognitive load to developers in GitHub at all if it's something that they can't fix. If it's something that only the owners of Brakeman or that Lambda can fix, like why even bother people in the pull requests? So because we control every API call in this entire flow, we can actually just suppress it. We can suppress from all the pipeline checks that, hey, Brakeman actually never even ran. Just check out the other stuff that did, if there's any action to take on that. And this doesn't mean we're suppressing the alert from Brakeman at all. What we're doing is reducing the burden on the team managing Brakeman because we're filling up their dashboard. So here's a default Datadog dashboard for the Brakeman Lambda. They can come and debug this as they see fit in their own time. They're not on call. They don't have to respond immediately, and they're not blocking any CI pipelines in GitHub. And so one of the cool things of setting up a flow like this is we actually have an extremely talented team at Chime working at service-to-service authorization and authentication. If you don't know what that means, that's totally fine. Just know that they had a custom enough way that they couldn't just roll up rules in semgrep. It required spinning up their own automation, very custom configuration checks that had a lot of dynamic elements to it. And really what they wanted to do is nudge developers to use the right authorization schemes over time. They wanted Slack alerts for every invalid configuration. And, spoiler alert, do we have a tool or a paved path that can kind of solve their problem for them? And that's exactly what they chose. So we rolled their form of automation fleet-wide via Overwatch. And it's not exactly an AppSec example, right? It's not like running semgrep or Brakeman. This is slightly modified, but still fits the paved path model. Going even further, and this one excited me a lot, is we had engineering teams outside of our security team reaching out to us. They're like, hey, we heard about a tool that can nudge people to do the right thing in a different direction. It can give us Slack alerts. You can deploy it fleet-wide on, just one YAML configuration. We're deprecating a database, and we don't want people to be using this database pattern anymore. Can we add a rule to Overwatch? Of course, we said yes. And so here's a semgrep rule that basically they added to dynamically, prevent people from changing a deprecated path. And they had a rollout strategy for them. And that team completely owns that rule, but they're not taking any SRE burden. They don't have to flag all these anti-patterns or spin up their own automation and CI pipelines. They're just getting this through our paved path approach for their non-security use case. And so going back to the diagram, right? Like this flow, like a good way to think about it is sort of like Lego blocks. Each component is sort of independent. You don't have to use this entire diagram from left to right. We're not creating one right way to use it. You saw different scenarios where people are just taking advantages of what we've built and the flexibility we've done it with and just building on top of it. And so maybe you have, some automation you're happy with in an AWS account or a confined Kubernetes namespace, and you just want to drop a report in an S3 bucket and take advantage of the APIs that we have with GitHub and Slack. That's possible too. You can skip everything in the middle. Totally up to you. And surprise, surprise, like most engineering projects, things are not linear. I wish they were, but they're really not. So there's bumps along the way, and especially if you're building something like this from scratch, like a platform from scratch, most likely you will regress first before things get better. And so there's some examples of, we didn't have our Terraform module, and so until we had that, it was slightly harder to spin up a Lambda. So all these things can kind of cause different sort of bumps and local maximums as you're going forward. And it's not a linear path. I think this is pretty obvious for most engineering projects, but it's worth reiterating. And so with that, just like some key takeaways, we totally understand Overwatch doesn't fit everyone's organization. It won't, or this approach won't. But can your organization sort of benefit? And by your organization, I mean your security engineers, your developers, sort of benefit from a paved path-like approach to managing your automation. Burnout's pretty prevalent in our industry. I don't think we need to make this problem worse. And if not through Overwatch, I think there's a lot of other projects or vendors, depending on your requirements, because they'll look different than our requirements, that could fit your needs. So Coinbase has had a project for a very long time. I think it's fantastic. Again, you'll see where it deviates from our approach, where we've split up our automation and we're heavily leveraging the serverless aspect of it. But if one image works for you and all the automations rolled up, would highly recommend you check out that project. In addition, we used the SemGrep app pretty successfully for a very long time while we were building up the capabilities of this platform. It has fantastic commenting. You can deploy it org-wide really well. In fact, one of the downsides was it made our other tooling look bad because all its triaging is good. It's how do we get Brakeman to look that good too? Hence coming back to our paved path approach. And so lastly, just wrapping up, whether you love or hate this approach, we'd love to hear from you. Here's some ways to contact me directly or our team. We do intend to write more about this project, but if you want us to prioritize open sourcing it, or you think this would fit your organization, definitely let us know. It'll help us prioritize that roadmap. We are not hiring as much as we'd like to at the moment, but we are hiring for a security engineer in the data security space. That should be coming up on our careers website soon. There's lots of other cool projects happening at Chime. Like this one. And lastly, thank you so much. I know it's a choice being here. Deeply appreciate our time.
Folks in the audience, we have a little bit of time left for our next speaker. Folks who want to ask a question, please raise your hand and speak loudly or ask to have the mic so everyone can hear what you're saying and understand what beautiful thoughts you have.
Hey, Sanchay, really interesting work. I was curious about how you think about kind of the filtering or the aggregation layer on top of these alerts. So I assume that, one of the advantages is you've got a lot of, you're able to give the alerts in context, but do you see a lot of false positives and how do you address that?
Yeah, fantastic question. So really, we try as much as self-service to whoever's spinning up the automation. One thing we've seen in practice is security can be very specialized, right? So it's hard for one engineer to know kind of all the details about all these different types of security tooling. So really what we try to do is just give the flexibility to whoever's spinning up the automation to go tune the alerts correctly, like all the versioning of Lambdas and all that, to let them test out enough so that they're kind of happy with their results. But we have basically built out in the platform some certain types of primitives to ensure that people aren't getting blocked or spammed. So for example, for any new form of automation rolling through our platform, we'll automatically ensure that you can't block pipelines. It's just like the default until we get some data. Again, we control all the data throughout the entire flow. So until we get data that kind of indicates that, hey, people are actually fixing this or there's a good sort of hit rate, then we can kind of open up those possibilities automatically. But that's one way we try to look at it. Oh, I see one one hand. Mukund there. Yeah, great question. So I think the question was, and sorry, I didn't repeat the previous question, but I think the question was, what do you do when you need a copy of the full code and not just the diff code? So certain forms of automation. Certain forms of automation operate a little bit differently. So things, scanners like Brakeman need a full copy of perhaps the code to performance execution. Things like CodeQL. SemGrep can just operate on a diff. And so the platform is just giving you all those options basically. And so that S3 code caching step, it will upload both a diff and a full code copy. And depending on what your automation needs to pull down and operate on, it can just pull the right copy. But the actual parsing of it is happening by the platform. So yeah, hopefully that answered the question.
Thank you.
See one hand over there. Oops.
Hello. Yep. Okay. So what do you think about individual pull request scanning versus an entire repo scanning? The use case that I have here is maybe 15 to 20 lines of code pull request might not be containing the security, input validation, or any kind of mechanism that we want to actually check. So which basically triggers some kind of false positives for the developers, right? So in those particular situations, how do you guys actually handle it and fine tune it?
Right. Great question. And just to make sure I'm understanding the question correctly, essentially what you're saying is, hey, like the diff only modified, like let's say 15 lines, but without the full context of everything happening around it, I may miss a vulnerability. So how do we handle those type of situations? Is that the question?
Even with the false positives. I mean, let's say, for example, some kind of vulnerable function has been used and you are basically flagging it out. But at the same time, the developer might be implementing some kind of controls at a different stage of that particular code.
Right. So basically, great question. It's just so like, how do we get the context from all the other things that was not modified to get the best answer to whether this is a vulnerability or not? And actually, very related to Mukun's previous question, what we do is if an automation requires a full story, compiled code or full code to give you the more concrete answers, we will let it do that even at the pull request level. All it will do on top of that is once it's fully computed, the full code and it's gone through everything, what we will pull out is if the vulnerability truly was created by modifying those files. Like, did the net new files really cause this new vulnerability? And if so, we will report it back in the pull request. If not, if that wasn't the case and that vulnerability is just lurking around from some other means or legacy code, we're just uploading it regularly into the GitHub Advanced Security dashboard, but not on a pull request level. That's just happening as sort of a nightly rollup.
Okay, and doesn't that slow down the scan process?
The full code, technically it doesn't, because the Lambdas really, because we're caching one copy of full code and each Lambda doesn't need to pull its own copy and operate on it. For the most part, all the Git stuff is already taken care of. And so if a Lambda fails, it can just retry from the point of pulling that, zipped copy of the code it needs and then to operate. Typically, we just put a 5-minute timeout and every scanner you saw is able to operate, within that timeout, but we can increase it slightly if we need to.
Okay, thanks.
Great questions. Thank you.
Big vote. We've got for question.
Awesome. Thank you so much.